Hello, I'm back. This is my second time recording this one. I know I promised I wouldn't edit, and so, does it really count as an edit? Okay, so we have this problem from the homework, and the solutions do it the scalar way, and so I'm going to show you how to do it the vector way. So I've left this free body diagram up here. We have point O here, we have three reaction forces, X, Y, Z, and then we have three tension cables. We have AC, BD, and BE. So those are three, and that together that's 6 unknowns. And then we also, the only other force is this 400 kilogram weight acting right here. So what we need to do is we need to first find, so FAC is going to be equal to the magnitude of FAC times the normal, or times this little unit vector, and then the same thing for BD. And BE. So our goal is to find these three, the little unit vectors. So NAC. All right, so I'm going to do each of these in a different color. So we start at point A. We're going to go from A to O, and that's in the negative Z direction, and that's 2 meters. And then we're going to go from O up to here, which is 1 meter in the Y direction, and then from here to C, which is negative 1 meters in the X direction. So minus 1 I hat plus 1 J hat, and then minus 2 K hat. Then we need to divide it by the magnitude of that, so minus 1 squared plus 1 squared plus minus 2 squared. Great, 1 down. And then NBD, because it is NBD, am I right? All right, so this one we're going to start, we need to start at point B, and we're going to go 2 meters in the negative Z direction, and then up 2 meters in the Y direction. So that'll be plus 2J, and then minus 2K hat, divided by square root 2 squared plus minus 2 squared. One more, NBE, and this is the easiest one because it just goes from B to E, that is a minus 2K hat, and so we can already kind of see where this one is going, I think. Technically, I'll just write square root of 2 squared is, of course, 2, and so that'll be minus K hat. Great, so now we have our three forces here. And what we need to do now, I'm going to actually take a second and turn those into decimals. So as I do that, you can ponder. What do you want to ponder? I don't know. What is worth pondering? If only there were some current events happening that were super stressful and, you know, things like that. So minus 0.817. Okay. The next one is 0 to minus 2. I guess I should have known what that would be. So that is 0.707 in the J hat and minus 0.707 in the K hat. And then this last one is already normalized. So there we go. All right. So what is next? Well, we have to figure out which point we want to take the moment around. And we have a couple options. We could do maybe A or B, but the most obvious one is point O. Usually if there's 3 unknowns acting at a point, that's where you want to take your moment around in statics problems. And so if we do O, we won't have any of these involved. We'll just have FAC, FBD, FBE, and the weight. So the sum of the moments around point O is 0. And that's going to also be equal to our OA, which I'll need to find. cross FAC plus ROB crossed with FBD plus ROB once again crossed with FBE plus RO to the weight, which I'll call W, crossed with, if you look, Y is actually vertical here, Z is in this direction, so all the weight is actually in the negative Y direction, which may or may not be why I had to redo this problem. Oops. So J hat. Great. So I'm going to need to find each of these. So I'll do that over here. ROA. Actually, is that visible? Let me move up a little. I think the other problem might start to get in the way, but ROA is, all right, so I'm going to erase our previous stuff before I do this. So just to talk about looking at these graphs are isometric graphs in 3D. And so usually when at the dimensions, like for example, this one here, it's a measurement of the y-axis, and the way it's telling you that is you have, like this arrow is telling you it's in that vertical direction, and then you have this line here, which is telling you to measure it relative like to where it intersects here, if that makes sense. So same thing up here, you'd follow that one to this point, and you can always like draw these, always you're looking at parallel lines to your axis, if that makes sense. So your x, y, and z axes. Okay, so the vector from O to A, we start at O. I should do this in color. O to A here, and so that'll be 2 meters in the K hat direction. Easy peasy. Our O to B is going to be the same 2 in the K, and then we're also going to add a positive 1.5 in the X. So 1.5 I hat plus 2K, and then we only have one more. ROW is 0.75 in the X and 2 in the K. Lovely. Okay, so now we may one more thing also, because of these equations down here in the bottom right, or left, oh God, in the bottom left, we have a scalar times a vector, and we can always pull scalars out of the cross product. So this is going to be equal to, for example, FAC ROA crossed with the normal, the unit vector AC. And then I can just do that for all of them. Oops. FOB, ROB crossed with NBD plus FBE ROB crossed with NBE, and then plus this one I'll just rewrite. J. There's some stuff here. Great. I'm going to make a copy of our little R's over here so I can read them as I... Oh, did you do it? There you are. Let's try to slide that over here. Take it back now, yo. Why can't mouse? Let me click. Let me click. There we go. And delete this, or I'll just erase. Okay, so we have 4 terms. So if we're doing it the determinant way, which I'm doing it this way if you didn't watch the earliest video because people in class told me they liked it that way more. So some of the moments around O is equal to 0. It's also equal to I hat, J hat, K hat. So we want ROA, which is 0, 0, 2. And this is going to be, we need to put the FAC here on the outside. And then NAC is over here, minus 0.408, 0.408 minus 0.817. Great, that's one down. Plus, I'm going to draw a little squiggly over here so I can do it vertically. All right, plus F, this should be a BD. FBD, I hat, J hat, K hat. So ROB is 1.5 in the I hat, 0, 2. And then down here, this force is 0.707, and minus 0.707. All right, FBE. I hat, J hat, K hat. Same vector. The force, though, is now only in the, not minus k, that should be minus 1. Minus 1. All right, and finally, this one doesn't have a thing on the outside. It is ROW, so 0.7502, and then the force is all in the negative j direction, and it's minus 9.81 times 400. Okay, now I can slide over. Was it worth it? I think so. All right, so all of this first one, we have I, and let me just put the FAC here now. So the I1, we're going to do this determinant, and that'll be minus 2 times 0.408. And then the J's will be, it'll be also negative because the J components have an extra negative. So we've got 3 minus signs bouncing around in this one, and 2 of them cancel each other out, so we're left with 1. So that'll be 2 times 0.408 as well. Oh, I need to put my I, my J, and K is nothing. Okay, plus F, B, D. So the I here is going to be minus 2 times 0.707. The J is minus 1.5, I believe. Or it'll be plus, because this is a minus sign, and we're going to flip it because it's J. So plus 1.5 times 0.707 J, and then the K is also times 0.707, right? Yeah. K hat. All right. So F, B, E. We have I, no I component because of the zeros, no K component either because of the zeros, so we'll only have a J. So J should be plus 1.5 J. All right, and then finally, this last one. So last one, I should be positive 2 times 9.81 times 400 kilograms. Oops, I didn't mean to close the bracket there. So that is the I hat. Right, yeah. The J hat is 0, and the K hat is a negative of negative 0.75 times 9.81 times 400 J hat. Okay, so, and all of this is equal to 0. What we need to do now is write this as a system of equations with the variables on one side, so something like this. It'll have a 3 by 3, and then we'll have FAC, FBD, and FBE. and then that'll be equal to a 3 by 1 vector. Okay, so we need to write it in that form. So if we gather up, oh wow, that was unexpected. All the FAC ones are going to go in the first column of the matrix. So minus 2 times 0.408, minus 2 times 0.408, and 0. Great. All these ones are going to go in the second column. Minus 2 times 0.707. I should use parentheses. Plus 1.5 times 0.707, and then plus 1.5, 0.707. All right, one more. This last one, 0, 1.5, positive 0. And you may ask, what happened to the weights? Well, my friends, the answer is I moved it to the other side. Why did he lose the weights? To get to the other side. Oh, that's not an equal sign. This is a multiplication. A 3 by 3 matrix multiplied with a 3 by 1 vector. I'm going to move this over a little bit. Why is it so hard to grab stuff in OneNote? Okay, so on this side, we want the negative of this, so it'll end up being minus 2 times 9.81 times 400, and then down here it'll be plus 0.75 times 9.81 times 400. Sorry for this being super messy. I'll rewrite it in a second. I just had to slide this over. All right. So this will be minus 2 times 9.81 times 400, put in the parentheses, and then the other one is 0.75, should be positive, plus 0.75, and 81 times 400. Okay, so at this point, as far as the physics is concerned, your job is done. You have a system of, well, at least for the moment, we still have to solve the other ones. You have a system of 3 equations, and we have 3 unknowns. And let me just pull up the solutions document real quick and show you how it compares to that. So he did, the TA who wrote these last year did it as the scalar version. So let's see if they match. And I guess it'll be, let's see, minus 2 times TBD, 2, what? Okay, minus 2, 1.5, I'll figure that out in a second. 0. Oh, he had this on, I see, all right. Yeah, I've moved them to the other side of the equation, he's kept them on the left side here. Great, so this is the 1.5 times the 0.707, and it looks like they all match. I'll draw the figures to show how to get these in a second, but first I'm going to get through the vector one. So at this point, what I am going to do is I'm going to pull up MATLAB off screen, and I am going to type all of these out. And if you're in an exam, I guess I can talk about that. I can't remember if I talked about it in a different problem or if it was the earlier version of this video. But basically, if you have a calculator that can do this, do it in a calculator. You shouldn't be eliminating by hand. But on exams, we'll usually give you easier systems of equations to solve. Rather than full 3x3s. 3x3 is definitely the biggest any person should ever do by hand. IMHO. Because we have the whole nice algorithm for inverting matrices or whatever, and my jolly if I just don't want to use it. Okay. 2408, 2707, 0. Minus 2 times 408. 1.5. Ah, I put in a plus. Okay. You're hearing me comment in real time about stuff that you cannot see. You must simply believe. Okay, and then on the other side, 8b is equal to minus 9.81 times 400 times, let's see, minus 2, 0, 0.75. That's a column vector. Okay, so now I should be able to do that. Three rows, one column. I'm just going to lin solve A, B. Alright. So here we go. I'm going to paste that in here so you can see it. Wow, this video is a lot longer than I meant it to be. There. And then just so you can see the matrices, I'll do this guy too. Paste. Alright, so I stuck that in there. I know I should be able to do the like backslash operator, but it got mad at me and I don't have enough time to troubleshoot in real time. Right, the forward slash operator, whatever. The A divided by B one. Alright, so this is minus 4,000 newtons is the, oh I guess I should say what these are. So this is TAC, this, and I'll just, TAC equals minus 4,810 newtons if I'm rounding. AC, T BD is minus 2,780 newtons, and TBE is minus 654 newtons, which oh yeah, I guess did I draw my signs the wrong way at some point? It doesn't. Let's find out. They are the right numbers, but I must have put in a minus sign somewhere. How strange. Maybe the minus sign is over here. Maybe Oh. I found this is my extra minus sign. Oops, I shouldn't have put that in. So I'm going to go ahead and flip these over to positive as they should be. Boop, boop, boop. Alright, well those are the right numbers. Alright, now the hard part is done. Thank God. You're almost rid of me. So what's left now? Over at our free body diagram, which I should just make a copy of this, I guess, and move it all the way over. We'll see. Why are you so slow? Computer. Control V. No? There you go. No, not again. No. I really should have. Okay. Mistakes were made. Alright, I now have accomplished this. Goodbye. Great. Okay. So the only unknowns left are OY, OZ, OX. So we want to do sum of f of x, sum of fy, and sum of fz is equal to 0, 0, 0. And the part that is a bit unfortunate about this, we're going to need to break up these other forces into their components. So to do that, I will need their unit vectors. So I'll go ahead and copy those. Laptop. No. Hopefully you can skip this part of the video. And if not, sorry. Thank you. Good luck. Paste. There we go. Oh, it's going to double paste. I really should have plugged my laptop in so it didn't run really slow. Is the lesson we're learning from this. Okay. So I'm just going to leave it here. All right, this is NAC and BD and NBE. Okay, so the sum of fx equals 0, so that's going to be equal to, we're going to have OX in here. We're going to have the x component of each of these forces, and that's it. This force doesn't have an x component, it only has a y component. So, FBE, no x component, right? Nothing. Same thing for BD. So, the only x component we have is going to be plus, so the magnitude FAC times minus 0.408, and that's all going to be equal to 0. And we found that FAC was what? 4,810. So OX is going to be whatever that is, positive. 0.408 times 4,810. 1,960 newtons. All right, one down, 2 to go. Okay. Where are you at? I've lost my mouse. It's not just you this time. I actively cannot see it. Okay, sum of f y is 0. Oh my god, it does not like how big this document is getting. Is equal to OY plus, so the y components are going to have NAC, so we're going to have FAC times this one, so 0.408, and then we're going to have NBD times this one, FBD times 0.707. And those are, FAC is 4810, OY plus 4810 times 0.408, plus BD is what? 2780. 780 times 0.707. And that's all positive, I believe. This is y, right? Oh, and I need the weight, that's why. Yeah, alright, so I also need to add in, there's one more, minus mg. So minus 400 times 9.81. Alright, so 400 times 9.81 minus 4810 times 0.408 minus 2780 times 0.707. Is that right? 400 times 9.81 minus this. Oh, it looks like it's within a rounding error, it's 0. So when I plugged that in, I got y is like 4 newtons, but no, but it looks like it's actually supposed to be 0. So I guess what that means for us basically is, wow, this is long. CA and DB are holding all of the y force. There's no y force being transmitted to point O. All right, one left. And it is the sum of FZ. And that'll be minus 0.817 times, what are you? I can't think anymore. 4810. And then minus 0.707 times, what is the 2870? All right, one more. And minus k hat is just 1, so minus 1 times whatever BE is. BE is 1654. All right, so I'm going to plug that into my calculator. 3810 minus 0.707 times 2870, times minus 1654. So minus, does that match the thing? So this is plus OZ is equal to 0, so OZ is like, I got 7,610. I think my rounding errors are coming back to haunt me here. Maybe I shouldn't have been rounding so cavalierly, or maybe I made like a little math mistake somewhere. But it's on the right order of magnitude. What are you? 48, 1962. Well, did I make a typo? Yeah, this isn't interesting to you. Okay. Anyway, that took a while. Oh my god, this video is half an hour. All right, one more thing. I was just going to show really quickly how to see the picture that the other TA drew. And if you just care about the vector stuff, you can go home. Like I said, you can just don't worry about this anymore. I'm going to take you, and I'm going to screenshot you and move you all the way over here. All right, so the way to see this way of doing the problem, the scalar way, is to imagine different pictures, sort of. So if I had the picture where this is the z-axis, this is the x-axis, and the y-axis is coming up at us out of the plane, this would be point O, and then over here we'd have A and B. And so this would be force BE. This would be force BD, but only the HZ components, so HZ component. The weight is technically it's out of the plane right here, so that won't actually contribute anything. And then over here I have this force FAC, and that's again the XZ projection. So that's what he's doing here. This is for the y is coming out of us, so it's like a 2D problem. So he's doing some of the moments around origin y, and this from So from O here to point A, that is 2 meters. So that is the 2. And then the projection of AC down into the OA plane, if you did the triangle stuff, is this 0.408. So, and then it's negative from the right-hand rule, basically. So you can just R, and then, for Y, that one doesn't actually contribute to Y, does it? Sorry, there's a little bit, so this has a x component and a z component, or yeah, x and z, and so the x component does contribute. The z component does not. This is why she teaches it the vector way, not coincidentally, because you have to remember all this stuff. So the z component is along this line, so it doesn't contribute. So it's 2 times this 0.408 TAC. Right, and so you would have to know, you'd have to figure out the x, yeah, this is the x component. So this is the x component of TAC. Pen. Right, and then one more, this one, this is a, where's the, oh yeah, so that's, sorry, I meant to write this one, it's that. This one, 1.5 times 0.707, so the 1.5 is right here, or right here on the 2D problem, 1.5 meters, and then that's the same as this distance up here. So we have to find the, what would that be? There's no x component to either of these forces, so we need the z components for each of them. So the 1.5 times 0.707 TBD, this is the z component. And if you do r crossed with f, it'll come out of the plane, so it's positive. That's this one, and then the same thing for this 1.5 times TB is entirely in the plane, so plus 1.5 TB. And technically that's the z component too. And so if you want to do it the scalar way, you have to do this for all 3 pictures, basically. So you'd also have to see the one, what would it look like? Y would be going this way, z would be going this way, x would be coming out of the plane, and there'd be the weight acting right here. This is the mg, and that one you would see the force AC, and then the force BD, and the force BE. They all pass through that point, and then way over here, oh man, yeah, this is why I don't want to do this problem this way. You'd have OZ, OY. Look, it's not fun. I don't like doing it this way. So take my advice for what it's worth. If this is helpful for you, go ahead and practice it. This is now a 40-minute video, so if you made it this far, geez, congrats. Good luck on your exam, and I'll see you tomorrow. Maybe.